Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, why we have to use the synchronized block in Java. Let me answer this question along with practical demonstration. So, what is the use of the synchronized block in Java? In Java programming, we can create a block known as synchronized block. By specifying the synchronized block, what is the advantage or what is the purpose or use? I'm going to explain, guys. So this is specially used, the synchronized block is specially used in multi-threaded programming. You see, in a single Java program, when you have multiple threads running parallelly at the same time, there is a possibility that these multiple threads can try to update the value of a single variable at the same time. What happens when one thread is already trying to update the value of the variable, another thread is going to disturb that process and interrupt that thread and try to change the value of the variable to some other thing. Like that, a conflict will be there. For example, guys, if you take an example of a hotel, okay, where some 100 tables are there and all the people, okay, who need to you know, who need to have lunch or dinner or breakfast have stepped into the hotel and have sat on the table. And that particular hotel management to accommodate all these 100 chairs and all, 100, tables and all, they have appointed not just one waiter or, server. They have appointed like around 15 to 20 people to serve the 100 tables. So there may be some situation where at the same time, one server, if it is going, one server or waiter is going to take the order from the table, same time, another server may come to the same table and again repeatedly take the same order. Okay. So there is a possibility. There is a possibility that the same table can be served multiple times by taking multiple orders in a duplicate manner. Same happens in Java programming in multi-threaded environment where multiple threads, okay, though they are designed to perform different activities, may try to perform on a single thing at the same time, because of which interrupted exception kind of exceptions may come. Okay. So, but what if you want to make sure that that particular variable for which the threads are trying to update the value should not be updated by multiple threads at the same time to avoid the interrupted exception. Multiple threads should not come at the same time and update the value of the thread. Well, one thread is already updating the value of the variable. Other thread should wait until the value of that particular variable is updated. Other thread should wait. Okay. And once the thread has completed the task, the other thread will try to update the value of the variable. While that particular thread is updating the value of the variable, the next thread should not come and disturb that. It should wait. So how to make sure that how to protect that particular updation of the variable so that multiple threads do not do the activity at the same time, because of which we may get interrupted exception? The answer is with the help of synchronized blocks. With the help of synchronized block, we can avoid, okay, we can put that, we can provide that updation of that particular variable code inside a synchronized block, okay? And by doing that, right, the value of the variable can only be updated by one thread at a time. Okay, though multi-threaded environment is there, still only one thread can update. Other threads will wait. Okay, and because of which things will go fine. For example, with example, I have to with practical demonstration. If I explain this right, you will get more clarity of this particular answer for this question. For that, I'll switch to Eclipse IDE, guys. Here under one package, like I'll create a class and I'll just say name this class as my account, bank account or my account, whatever it is, bank. You know the example of the bank, right? Click on finish. In bank, what will be there? In bank, generally, why we have to check our bank account to see how much amount is there in our account, how much balance is there. Okay. So here int balance amount or balance. Some variable I'll create. I'll assign this balance to 0. Initially, the balance in this particular bank account is 0, and I would like to deposit some money. Okay. I would like to deposit some money. For that purpose, public void deposit. Okay, deposit method I'll create. Using this deposit, I would like to deposit some amount. How much amount I would like to deposit? Int. Okay, int some I or something, some number, some amount. Okay, int amount I'll say. Otherwise, int amount, some amount I want to deposit. This amount should be provided as a, okay, when you're calling this particular method, you have to pass the amount. Such amount will be deposited into the bank account. How? I have to write the code like this. Balance is equal to balance plus amount. By writing this code, okay, this particular method is going to update the value of the balance from 0 to whatever the amount I want to deposit. If I deposit, 1 rupee here or $1 here, 0 plus 1, it will become $1. Okay. So now if I want to get the current value of this balance, okay, after depositing some money or before depositing the money, if you want to get the current balance, you'll create a method like get balance. Okay. What is the current balance? Return this variable value you have to return, guys. Variable value I have to return. The variable is of int data type, so the return type will be int. Now in this kind of situation, this is a normal program. I'm not implementing any synchronized block, etc. in this program. Very basic program. Just try to understand the basic program, guys. In the next level, I explain about the synchronized block and make this multi-threaded and. Okay, so like that. Fine. Okay, now in this case, what I'm going to do here, I'm going to create a demo class and with main method, normal program I'm writing so that you can understand the context first. After that, I'll go to the multi-threading and synchronized programs, synchronized blocks, etc. Okay, now guys, if I want to deposit some money, what I have to do, guys, I need to create an object for the bank account. Okay, bank account is equal to new bank account. Like this, I'll create an object for the this one. Okay, bank account class. Bank account ACCOUNT. Okay, I'll copy this. K is missing here, the name. Here I have to put K so that it will be gone. Bank account. Okay, like this, I create an object, guys. If I want to deposit some money, what I have to do? I have to say account dot deposit. I need to call deposit, and if I want to deposit, let's say 1 rupee into this bank. Okay, after depositing, if I want to get the balance, so simply I'll write system.out.println account dot get balance. I'll say the balance, whatever the amount I deposited, right? If I deposit only 1 rupee, the balance will be updated to 1 rupee here. And since this particular program is a single threaded program, you see main method is only running with the main thread is running. It is a single threaded program. Only one thread is running, which is nothing but the main thread. If you run this, you see you got the balance as 1. If you try to deposit multiple times, okay, still it is a single threaded program only, guys. This time you should get the value as 4 because 4 rupees you have deposited. So balance should be 4 at the end of the program. Hope you have understood this program now. But now I'm going to convert this into a multi-threaded program. Okay, how to convert this into a multi-threaded? Instead of calling this particular thing as part of code, what I will do here is anyhow at the end of the thing I'm going to get the balance. I'll keep it like this. But in between, what I'm going to do here is I'm going to create some threads, guys. Okay, I'm going to create some threads. Thread T1 is equal to new thread. T1 is a one thread. Okay, like this I'll write, and I'll create one more thread. Thread T2 is equal to new thread. And in the constructor of this, in the constructor, when I create this particular thread, right? Okay, when I create this particular thread, right? In the constructor of the thread, I'm going to create a function, guys. And easiest way of creating a function is by using nameless function, which we call as lambda expressions in Java. So there doesn't have any name. So circular brackets will be there before the circular bracket. This method doesn't have any nameless function or nameless method. Doesn't have any name, guys. If it has 0 parameters, then circular brackets are mandatory here. 0 parameters are there in this function, and you have to write this arrow symbol and write the starting and ending portion of the function or method. The starting of the function, ending of the function. Okay. So inside the thread constructor, I am writing, guys. Inside this, I'm going to write some code, guys. The code is nothing but I would like to write some code like this. For int I is equal to 0, I is equal to 1, sorry. I is equal to 1, I less than or equal to 1000, semicolon, I plus plus I'll write. After writing this, in this iteration, I'm going to call this deposit method, guys. Okay. So how to call that method? Account dot deposit. Every time I call this method, I would like to deposit a single rupee, single buck. Okay. Here, single buck. How many bucks will be added to this balance by this particular thread? 1000 times this is iterating, means every time it is calling deposit 1 means 1 rupee or 1 buck is getting deposited and the balance is getting increased by 1. And if I run this particular loop, loop 1000 times, 1000 bucks will be added to the balance, right? Basically. But here, unfortunately, there are no single threads here. There are multiple threads. This is one thread, another thread is also there. In this thread also, I'm going to write the same as it is logic. This thread is also going to do the same thing, guys. This thread 2 is also going to do the same thing. where again it's going to deposit the rupee 1. Okay, like the same thing, it's going to do that. Here you can actually make it like this, it's more better. Okay, this is a better way of writing. Fine. There are two threads. This also will add $1,000. This also will add $1,000, right? 1,000 rupees or $1,000 or whatever the currency you want. Okay. Now I want to start these threads. I want to start these threads. T1 dot start, I have to say. Then T1 dot, T2 dot start. I want to start these two threads. So I'm starting the two threads. Two threads to deposit the money will keep running simultaneously. Okay, this thread will be repeatedly running this many times. You see, this is trying, this particular thread, it is running, right? It's keeping on repeating and adding balance, increasing the balance by 1 1 1 1 like that. And second thread also at same time is trying to increase the balance of this particular same variable. Both the threads are working on. Okay, the balance variable is getting updated by this both the threads at the same time, and every thread is trying to add $1,000 into that in a by calling this particular method 1,000 times, by calling the deposit method 1,000 times. But is this particular balance variable is now thread safe, or is thread safe means multiple threads will come and can interact with at the same time, right? Yes, it is possible. So there is a possibility that interrupted exception may come because of this kind of case. Okay, let's see what will happen, guys. Interrupted exception may come, or wrong balance may come, or something will happen. Okay, let's see that. Without that synchronized block, what is happening here? $1,000, here $1,000. Okay, here exception may not come. Here 1,000 means total 2,000 balance should come at the end, but I will not get 2,000 balance, guys. Sometimes I may get, but most of the times I may not get. If I run this code, guys, before running, guys, after starting these two threads, there is something like you have to ask the main thread. You see, apart from these two threads, the actual program has a main thread, right? I want to make the main thread wait and print this balance. For that reason, to make the main thread wait, I'll say join. I'll just join this particular threads to the main thread, so that main thread will not be completed until both the threads got executed. Main thread will not be completed. Here you are getting some kind of interrupted exception possible. I'll ignore the exception for a while. That's okay. Now this join method will make the main thread to wait until these threads are completed their work, and after these two threads are completed with their work, then main thread will be executed and remaining program will be completed. Otherwise, before these threads are completed, balance will be printed. Before this particular threads are completed, the balance will be printed. So we have to make the main thread wait until this particular two threads are completely added the balance. Okay, that's the reason we are joining this particular T1, T2 threads to the main thread, so that main thread will wait until this particular two threads are complete. Final, these two threads are complete. Remaining portion of the main thread will be completed. Okay, run this code and see that will you get 2,000 or something. Let's see that you didn't get 2,000. 1834. What happened to the remaining balance? Where it gone? Because of the at same time the multiple threads are trying to update the value, right? Maybe both the threads try to update the value by one itself, and because of it, some bugs are lost here. Let me run it again. Every time you'll not get the same value, guys. Every time you may get a different value here. Luckily, we got 2,000, but it's not always, guys. Third time I'm running, you see, we got 2,000. Again, we are lucky. Again, I'm running. Not every time we'll get, guys. Not every time we'll get. We just keep running, guys. Just keep running. Okay, most of the times we are getting now. Just click on this and see. Okay, almost every time. You see, 1983 came, 2000 came. Not always 2000 is coming, but sometimes some different number is also coming, depending on how the threads are being most of the time 2000 is coming, but in between sometimes in between sometimes some different numbers are coming. That means there is no guarantee that the balance amount will be 2000, because here 1000 total. What if I put this particular balance inside something known as synchronized block, and here I need to write this keyword and provide this like this, synchronized. Okay, like this we have tried, guys. Synchronized. Okay, synchronized keyword we have tried. And this, what the purpose of this particular block is very straightforward, guys. Okay, inside this synchronized block, multiple threads cannot interact with this variable at the same time. Synchronized, even though this is a multi-threaded programming, synchronized block will make sure that at a time only one thread can access the balance, and remaining threads will keep waiting to update the balance. So once you have the synchronized block, now any number of times you write the code, guys, any number of times you run the code, there is no possibility. I'll try to run this third time I have run, fourth time I'm running, fifth time I'm running, sixth time I'm running, seventh time I'm running, eighth time I'm running, ninth time, 10th time. Not even a single time you are getting a different thing. Every time you are getting 2000. There's no possible. Sometimes in without synchronized block, right? Sometimes we got 1954, 1984 like that. But in case of when you make this particular variable part of this updation of the variable part of the synchronized block like this, you write and part make it part of the synchronized block. You know, only one thread at a time can deposit the balance and update the value of the balance. And this is what is the purpose of the synchronized block, guys. So with practical demonstration and theoretical explanation, I've answered this question for you. So if you want to practice the same program in your personal machine or personal laptop, you can take a screenshot of this code. Okay. So hope guys you have taken the screenshot of this code and hoping that you will practice this particular code in your local machine or personal machine or personal laptop. So with this note, guys, I am just winding this session up. So I have explained you theoretically, practically, and was able to answer this question for you. If you can answer the question like this, right, with this kind of examples and all, when you can kind of get this question in the interviews, then the interviewer will definitely get impressed. So guys, and also I'm putting all this code inside this notes also. If I expand this, whatever the code I demonstrate is also part of the notes. You can also check the notes, guys. Fine. So that's all for this session. Thank you. Bye-bye.